Bismillahirrahmanirrahim. Assalamu alaikum to all of you. This is Abdul Ghaffar Abbasi here to conduct chemistry class of HSC Part I, Chapter number 1, Introduction to Fundamental Concepts of the Chemistry. So today we will discuss about a very important topic, that is stoichiometric calculation. So first of all, what do you mean by the stoichiometry? Definition: the quantitative relationship among the reactants and the products in a balance equation is called stoichiometry. Stoichiometry is basically the branch of chemistry in which we will calculate the mass, volume of the reactant or product. If the mass of the reactant is given, then we have to calculate the mass or volume of the product. If the mass of the product is given, then we have to calculate the volume or mass of the reactant. So there are some important points, assumptions of stoichiometric calculation which are mandatory, which are very important to understand. So first of all, we have to understand these topics, these main assumptions, points, then we will be able to calculate the stoichiometric relationships or stoichiometric calculations. There are two important assumptions, points for stoichiometric calculation. Number one, reactants are completely converted into products. So that is the reason that initially in the equation, in the definition, we have discussed that there must be a balanced chemical equation. So balanced chemical equation will be considered when reactants are completely converted into products, means reactants and products are same, they will remain same, means their amount or number of moles will remain same. So in this way we can say that will be a balanced chemical equation. All the reactants must be completely converted into products. So this is the first very important assumption of stoichiometry. Then second is that no supplementary or side reaction occurs. What do you mean by the side reaction occurs? Now look at the I'm giving you the example. Through this example, the point number second will be very much clear. Say suppose this is the reaction of the carbon and the oxygen, right? So when carbon reacts with oxygen, it will produce CO2, carbon dioxide. This is the reaction, and look at here, it is balanced chemical reaction. And then we can perform the chemical calculations or stoichiometric calculations related to this chemical reaction. But this is called the side reaction. When carbon reacts with oxygen, it will produce carbon monoxide, not carbon dioxide. So this is called the side reaction or supplementary reaction. So as initially I have told you that all the reactants must be completely converted to form product, and there should be no side reaction. So this is the side reaction. When carbon reacts with oxygen, so it must produce the CO2, it will not produce the carbon monoxide. Now we are discussing in detail one by one the stoichiometric calculations. Stoichiometric calculation can be divided into three main important categories. Number one is mass-mass relationship, mass-volume relationship, volume-volume relationship. Let's look at, we are discussing one by one these relationships in detail along with calculation. Number one is mass-mass relationship. In this relationship we can determine the unknown mass of reactant or product from a given mass of a substance in the balanced chemical reaction. So this is the main introduction or explanation or definition, you can say, of the mass-mass relationship. There will be the mass of the reactant or the product will be given, and through that given mass you can calculate the unknown mass of the reactant or the product. Now let's look at this key points related to the mass-mass relationship before we are going to solve the question. Now there are these 4 steps you must have to remember for the calculation. Number one is that, as initially I have told you, that write a balanced chemical equation, find the number of moles, find the mole ratio, calculate the mass, then we will be able to get the mass relationship. Now these are the 4 steps. We will solve the question through these step by step process, right? Second is that, okay, we know the steps how to calculate the mass relationship. Are there some formulas for calculation? Yes, these are the formulas which are involved in the mass relationship, calculation of the mass relationship. Formula number 1 is very easy, very basic, that number of moles will be calculated in as mass in grams divided by molecular mass or atomic mass or formula mass. This is the formula number 1, and where we will use this formula, go to the steps, find the mole number of moles. In this step number 2 we will use this formula. In step 2 we will use. Now the second formula number 2 is that mass in grams, calculate the mass in grams is equal to number of moles multiplied by molecular or atomic mass. So where we use this formula number 2, and look at the step number 4. Step number 4 is calculate the mass, so we will use this formula number 2 in the step number 4, right? So now let's look at the next slide related to the calculation of the mass relationship. Example number 1, calculate the mass of CO2 that can be obtained by heating 25 grams of limestone, and also we have to calculate the mass of the calcium oxide. So now look at the equation. As I have told you that we will solve this problem step by step. So number 1 step, as I have told you, that number 1 step is write a balanced chemical equation. Look at here, right? We have written the balanced chemical equation. Calcium carbonate decompose into calcium oxide and CO2. 100 grams is the molecular mass, formula mass of calcium carbonate, 56 of the calcium oxide, 44 of CO2. When you add 44 and 56 you will get 100. So this equation is completely balanced. In this equation what is being asked, that we have to calculate the mass of the CO2 and we have to calculate the mass of the calcium oxide also, but with the help of the, as I told you that there will be given mass. So given mass is 25 of the limestone or calcium carbonate. So through this given mass we can calculate the mass of the unknown substances like calcium oxide and carbon dioxide. So the step number 2 is find the, look at the steps. Step number 2 is the find the number of moles. So we will find the number of moles of that compound when we are going to the question. The given mass is of the limestone, so we will calculate the number of moles of the limestone. So number of moles of calcium carbonate is 25 given mass, and that will be divided by its molecular mass, that is 100. So we will get 0.25 moles of the calcium carbonate. Now the step number 3 is that we will discuss the mole ratio. Mole ratio means, look at this formula. The calcium carbonate has 1 mole, so it will be 1 ratio, and then calcium oxide similarly 1, and what about CO2? That is also 1, right? So the mole ratio is 1 1 1. So look at this one, step number 3, find the mole ratio. If 1 mole of calcium carbonate produces 1 mole of CO2, right now we have calculated 0.25 moles of calcium carbonate, so definitely it will produce also the 0.25 moles of CO2. So if the 1 mole of calcium carbonate produces 1 mole of calcium oxide, similarly 0.25 moles of calcium carbonate will also produce the 0.25 moles of the calcium oxide because their mole ratio is same, that is 1:1. Now we have also calculated the number of moles through the mole ratio, step number 3. Now we will solve the step number 4, that is the calculation of the mass. So mass of the CO2 we can calculate, as you know the formula I have told you in this slide, that how we can solve the mass: number of moles multiplied by atomic mass or molecular or formula mass. So number of moles is 0.25 of CO2 and molecular mass of CO2 is 44. Answer will be 11 grams. Mass of calcium oxide will be 0.25, will be number of moles multiplied by the atomic mass or molecular mass, that is the 56. So the answer will be 14 grams. In this way, how you can calculate the mass of the unknown substance with the mass of the given in a balanced chemical equation. I hope you understood this first stoichiometric calculation, that is the mass relationship. Now we are moving towards the second, that is the mass volume relationship. This is little bit introduction explanation related to mass volume relationship. In this relationship we can determine the volume of a gas in a reactant or product. Whether the gas is in reactant side or product side, we have to calculate the volume of the gas in a given mass of the substance. The mass here, the mass will be given in a chemical reaction. So look at this very important two lines. According to Avogadro, 1 mole of any gas at standard temperature pressure, it will occupies the 22.4 dm cube volume. Any gas at, if we are taking the 1 mole, it will occupy the volume that will be standard, that will be 22.4. So the question is that calculate the volume of CO2 gas produced at standard temperature by the complete combustion of 20 grams of methane. Here is the given mass. Find the volume of oxygen also in this reaction. So we will go to follow the same pattern step by step. Write a balanced chemical equation. Here is the balanced chemical equation of the combustion of methane with the oxygen, CO2 and H2O will be produced. So 16 grams will be of methane, 64 will be of the oxygen, then 44 carbon dioxide and the water. So here it is being asked that we have to calculate the volume of initially CO2 and then volume of oxygen also. Next is the find the number of moles. Number of moles we can calculate. The given mass of the methane is given, so we will calculate the number of moles in this way: 20 divided by 16 gram of the methane. Answer will be 1.25 moles of methane. We have calculated the number of moles of methane. Now we will move towards the step number 3, that is the mole ratio. Look at the mole ratio in equation. Here is the 1 ratio of the methane, but 2 ratio of the oxygen and 1 ratio of carbon dioxide, and there is the 2 ratio of the water vapors. So 1 ratio is of the methane, 2 of the oxygen and 1 of the CO2. Now look at here. If 1 mole of methane produces 2 moles of oxygen, as it is very much clear from the equation, then if the 1.25 moles of methane, then definitely it will produce, you have to multiply it by the 2, then the answer will be 2.5 moles of oxygen will be produced. And second point is that if the 1 mole of methane produces 1 mole of CO2, then 1.25 moles of methane will produce same 1.25 moles of the CO2. Then last one is that volume of the CO2, and we have to calculate the volume of oxygen with the help of a formula that we will multiply the number of moles with 22.4 dm cube, which is standard volume. So volume of CO2, number of moles of CO2, that is 2.5 multiplied by 22.4, answer will be 56, and the answer of the oxygen will be 28 dm cube of oxygen will be produced. So this is the stoichiometric calculation. relationship number 2, that is mass volume relationship. I hope you understood this relationship. Now we are moving towards the last, that is the volume relationship. Here is the explanation related to the volume relationship. In this relationship we can calculate the volume of a gas, one gas, from the known volume of another gas involved in a chemical reaction. There will be one volume of one gas will be given, and we have to calculate the volume of unknown gas. Gases react in the volumes, and relationship between the volumes of gases in a chemical reaction was introduced by a scientist, that is Gay-Lossic's scientist, and that was the Gay-Lossic's law, and of the combination of the volume, which states that this is the definition of this law, that gases react in the ratio of the small whole numbers by the volumes under the similar condition of temperature and pressure. Just we have to focus here the mole ratio. Now look at the question: what volume of oxygen at a standard temperature pressure is required to burn 500 dm cube of ethane gas? What volume of CO2 will be produced? We have to calculate the volume of the oxygen, and we have to calculate the volume of CO2 in this relationship. Similarly, we have to follow the same pattern, that we have to write the balanced chemical equation. Here is the balanced chemical equation of the ethene, combustion of ethene, it will produce CO2 and H2O, complete balance equation. Then we have to find the, as I told you, that in this equation, in this calculation, we have to focus on the only on the mole ratio of the volume. So if the 1 dm cube, here look at here, 1 mole, 1 dm cube of ethene requires 3 dm cube of oxygen. Look at here, 3 volume of oxygen. Then if the 500 dm cube of ethene is given, then you have to definitely multiply by the 3. 1500 dm cube of the volume will be produced of the oxygen. Then in the second step, 1 dm cube of ethene will produce 2 dm cube of the CO2. So definitely you have to multiply by 500, multiply by 2. Your answer will be 1000 dm cube of the CO2 gas will be produced. So this is the calculation of volume relationship. Today we have covered this very important topic, that is the stoichiometric calculation, and we have discussed these 3 relationships: one mass relationship, mass volume relationship, and volume relationship. I hope you understood this topic. Thank you very much. Allah Hafiz.